Alright, so now for example 2. If we refer to example 2, part a book of mass of 8 kg is arrest on a rough slope, which is an angle of 20 degree to the horizontal. The book is held on the limiting equilibrium by a force of 10 Newton up to the line of the greatest of the slope. Okay, find the coefficient of friction and the magnitude of contact force. Right, so for this question, I have roughly draw the diagram for you to view. So we assume that this object is at the point, we hold it, okay, to prevent the item to sliding down, right? So if you prevent the item to sliding down, the frictional force will be poised up, right? So in this situation, if we want to form the net force equation for the perpendicular direction to the platform, so we can have a R equal to AD, okay, cos 20, right? So for this situation, we should get R equal to, the normal contact force will be equal to 75.2 Newton, right? And at the same situation, if we resolve the forces that parallel to the inclined surface, you have AD sine 20, okay, will be equal to F plus 10. Okay, so in this situation, we should able to find that F actually equal to 17.4 Newton. Right. So from this situation, for this resolving of forces, we are able to find R, we are able to find F. So as we know that if the system is going to move, okay, and the limiting equilibrium, so that we know that F will be equal to mu R. Alright, so in this situation, we were able to find mu will be equal to about 0.231, right? 0.231. So from this situation, if I continue to calculate this, okay, we were able to find that C will be equal to square root of F squared plus R squared. So that from this situation, we are able to find the total contact force, okay, is equal to 77.2 Newton. Right. So we answer the question, the magnitude of the contact force. Right. If the question asks you to find direction of the contact force, so you need to use the inverse tangent to find. Right. So this one for part A. How about part B? The question say find the largest force up the slope for which the books remains at rest. So I draw another diagram. Okay. So if this situation, the largest force up P, let's say P, right? And in this situation, we need to consider the box is going to move up, So we will apply the largest P. So normal contact force still here R, mg still here 80, but this time if the block is going to move up, so the frictional force will be here, F, different direction compared to the part A. So if we resolve the forces, R will be equal to 8g cos 20, and we have 75.2 Newton, right? And at the same time, we resolve the parallel to the surface, 8g sine 20 plus F will be equal to P, right? Okay, but we know that F equal to mu R. by substitute to the second equation, we will get P equal to 44.7. Okay, this is the largest force that you need to apply to hold the item. If you increase P some more, so what will happen? So if you increase P some more, you will overcome the limiting fraction and the block starting to move up, right? Let's say your P is 50, so the block will start to move up, okay, with a certain acceleration, right? Hopefully you can answer your question for example 2.